Hello everyone, today I'm going to talk a little bit about water in Unreal. Not the next gen stuff, there's plenty of advanced cutting edge features in 4.26, but for now I'm going to cover some of the basics, just getting you set up with a water material so that you can have large bodies of slow moving still water, oceans, lakes, slow moving rivers, big puddles, whatever you want in your landscape scenes. Without further ado, let's jump into Unreal. Here I have the output of my previous video, a landscape which I can paint a couple of different materials onto, but that's not super important for now. Ultimately, the point is that I have a landscape with a place for some water. So I've sculpted a few holes in the terrain by going to the landscape editor, sculpt tool, and then pressing shift and holding that shift key down. Which lowers the terrain rather than raises it. There we are. Now you should be able to see what buttons I press. So if you're confused about what I'm doing at any particular time, check the bottom right-hand corner of the screen, and you'll see everything that I press. Alright, so where were we? We've sculpted some terrain and we want to bring in some water. Before I do, there's one thing that I want to do, which is going to make our lives a little bit easier. By default, when you move around the scene, the camera sort of adjusts its exposure to show you the best image possible. But we don't really want that, because if we're looking at dark water, we want to know that it's dark and not have the camera auto adjust to be bright. The way that we do that is in our place actors, search for post-process volume. It's also under volumes. Somewhere in here, post-process volume. Simply drag that into your scene, and what I like to do is hit reset in the transform, just so that I know that it's in the center of the scene. But it doesn't really matter, because the next thing that we're going to do is in the details panel of our post-process volume, type extents, and check infinite extent unbound. And that means that no matter where we are in the scene, no matter where our camera is, this post-processing effect that we are about to apply will apply to the camera. What we're going to do is close all of these menus and look for, where is it? Is it in lens? It doesn't even matter, because what I'm going to do instead is just search for exposure. And that will bring up our list of exposure features. And you can see that by default, the metering mode is auto exposure. So it's going to sample the scene, see if it needs to brighten the camera, and if it does, if your scene is particularly dark, it will brighten the camera. And that's great if you have a game or a scene where you are moving around caves and then to the outside, and you don't have to worry about lighting your cave at the same level as lighting the outside. But it's not super great for us right now, because it gives us an inaccurate depiction of the world. So I'm going to move down to, oh, look at that, I've got all squares. I'm going to move down to min brightness and max brightness, and just check those two and lock min and max at 1. So now our camera isn't going to adjust, it's going to stick at the default exposure value of 1 exposures. I wonder if there's okay, there's some information there on what that 1 value actually means, but that's not super pertinent for what we're doing right now. I'm just setting both the min and the max at 1. Alright, now that we've done that, let's get started on the actual stuff of this video, the water. I'm going to be building off water that is supplied to us by Epic very kindly, called the water lake or the water ocean material. So in my content, with content selected, under my search bar in my content browser, I'm going to type water, and I should see that there are a couple of different water materials. You might not see the instance that's from earlier, as well as a couple of water textures, and I have a map called water map. You probably won't have that. If you don't see this, then chances are you don't have the starter content. If I hover over one of these, you'll see that under path, the path is in game starter content material. So all of this stuff is coming from the starter content. If you don't have that, go to add import, add feature or content pack, and then under content packs, select starter content. Add that to your project, and then you will have these assets listed somewhere under your starter content. So here we have 2 water materials. Well, this is going to be a very short video if we can just drag and drop these water materials into our project. We can't. Well, we can with a few caveats. And that's the reason that I'm doing this video. And I'll demonstrate the big problem by dragging a plane into my scene, double checking that my surface snapping is not on. If the surface snapping is on, then the plane will start rotating along with the landscape. And I'll just drag this in somewhere into my scene and scale it up a lot. I think the default plane is a 1 by 1 meter plane. So if I scale it by 100, I will have a 100 meter big plane, which is perfect. Almost perfect for my body of water. Maybe if I say 150, it'll fit a little better. And this is the plane that I want to represent my body of water. So let's take one of these materials and right-click, create a material instance, just so that we have some knobs to tweak. I'm choosing the ocean to start with, just to see what it looks like, and drag the ocean into my material. So that's something. It looks like there's a little bit of movement happening. It looks like it's sort of blue and teal, maybe like the color of the ocean that we would expect. But something's off, right? And the something that is off is that this material has been scaled up really, really big and taken all of the mapping of the textures that are inside the material and scaled those up too. The first instinct at this point might be to click on the material instance and see whether there are any options to change the scale. Because ultimately what we need to do is scale the textures down so that the textures of the ocean match more what we would expect. Unfortunately, looking at the material instance, there is no option to scale. So we're going to have to add that ourselves, which I'll get to in a second. Just to prove that I'm not crazy, if I take the plane and scale it back to 1 by 1 by 1, and then press F to frame in on it, that looks a little bit more like what I would expect an ocean to look like, right? With a couple of differences, but that's a good place to start. So one thing that I could do if I wanted is duplicate this object over and over and over again, and then I would have sort of tiled oceans. But that's ridiculous. Why would you do that? And also there's this other problem of this is a very clearly repeated tiled pattern. So instead what we're going to do is we're going to change the material itself so that no matter how big or small our plane is, we can adjust the scale of the material to suit our needs. Let me just delete all of those, scale this back up to, what did we say, 150, and hop over into the material editor. Now, the first thing that I want to note is that I'm not going to edit this material directly because this is one of the starter content materials, and I don't want to change that in case one day I want to come back and revisit it. So instead, I will duplicate this material by right-clicking, duplicating, and I have mWaterOcean1, which I will rename. Let's go with mWater_custom_ocean. All right. And now it's created a new material. I'm also going to delete the instance of the starter content material, just to keep things clean and not confuse me. But if we look at the path of this material that I just duplicated, it is still in starter content, which doesn't make sense because this is no longer starter content, it's now my own custom stuff. I'm going to drag this material into my materials folder, my own materials folder, so that I don't have to search for it anymore. I just know that it is within my materials folder. Good, excellent so far. Let's open this up and see what's going on. There's a lot of stuff going on here, and fortunately, for the most part, we don't have to look at all of it, but just to briefly overview what's going on here. Roughness is being set at 0.1, so we don't need to really worry about that. And the base color, both the base color and the normal are being blended at some point along this chain between 2 values. And those 2 values are ultimately coming in from texture maps. And the real magic is happening in this node here, the panner node, which you'll see a couple of times throughout. And what the panner node is just moving the texture, and each of these textures is moving at a different speed. And that gives you, since they're all sort of moving in different directions at different speeds, it's giving you this appearance that the water is shifting and moving with no extra calculations other than moving a couple of textures. So that's what this is all about, and that's what this is doing. Unfortunately, the texture coordinate is feeding straight into the panner. And the texture coordinate, each of these different texture coordinates has been hard-coded, has been set at a specific value to match a 1x1 square. So when we move that square up, we aren't able to change the tiling of that texture. So all we're going to do for the first step of this video is adjust this tiling value in each of these texture nodes with a parameter that we can then change in a material instance. So if we scale up the material, we can scale down the texture tiling. And the way that we do that is pretty simple. First of all, we need a scalar value or a single float to adjust. So I'm going to hold down 1 on my keyboard and press and left click somewhere on the screen, which will bring up this value, this 1. We could also right click and say constant and add a constant. They're the same thing. And I'll right click on this constant and say convert to parameter. And now I have the option to name what this parameter is. So I'm going to call this the water texture scale. The default value is going to be 1 because I want the default scale to be what the original designers of this material wanted. But then I'm going to add a slider between 0.00001 or something. That doesn't really matter. We might not even use the slider. But some value between 0 and 1 for the slider. And then we're going to adjust each of these texture coordinates before it goes into the panner. Now there's 2 ways to adjust the texture coordinates. The first is to multiply and the second is divide. They both do the same sort of thing, but in slightly different ways. If we were to multiply, what we're saying is that for each area where there is a texture, if we multiply by 2, for example, the mapping of that texture becomes double. So it fits 2 textures into where 1 was originally supposed to be. And then if we multiply by 4, it fits 4 textures into that single area, or 16 because it's a square. So with multiply, things can get a little bit confusing because the bigger the value, the smaller the scale looks. So more commonly what you see is scales which are divided. Because if we divide this texture by the scale value, the higher the scale value, the less of stuff is fitted into a specific area, so the larger it appears. So this way, when you create a high scale, the texture looks big. Let's see what that looks like. So we'll drag this divide into the panner, and then do the same process for all of these texture coordinates nodes. Let's actually copy both nodes, paste that in here, divide this texture coordinate. All I'm doing is hunting for all the texture coordinate nodes in this scene, this node tree, and there is, I think that's all the ones that go into textures. So there is one more here under large scale tiling. Yeah, let's do it. Let's see what happens. We might further down the line want to create a second option here, a second parameter for us to just adjust the large scale tiling a little bit, because this doesn't feed directly into a texture. But for now, I'm going to lock it into the general scale of this texture itself. All right, so hit apply, hit save, and let's pop over into our scene, create an instance of this master material that we've just created. So right click, create material instance, and drag that onto our water body. All right, at first it looks the same as what we had before, where the scale is sort of off. But if we double click into it, we now have this option in parameter groups to adjust the water texture scale. So let's turn that down a little bit. And you can see that we can start to see that we're getting a little bit more detail. And I'm going to forget the slider for a moment and just type in 0.001. That's a little too intense. 0.01. And there we have something that doesn't look bad. This is now an ocean type material, and it's doing its job. There we are. This doesn't look too bad. It's the beginnings of a water. All we've done is taken the default ocean shader and applied a little bit of scaling to it in our own custom version of that shader, so that no matter how big or small our water body is, we can adjust based on that size. So for example, if we did need to increase the size of our water a little bit, so instead of 150 we have to say 500, for example, the scale is going to be off a little bit again. But I can go into my material parameter, say, you know what, 0.02. And there we've got our material again. It's coming in with some pretty decent reflections. As a sort of first step to getting water into your scene, that wasn't too bad. We can do the same thing for the lake material. So I'm going to walk through the same steps that I just did for ocean with the lake material as well. Let's see what that looks like. I'm going to save that. Close that. Back in my content window, I will use my search bar to search for water. And now I've got all the other stuff that I've just created as well. This time I'm going to select the lake, right click, duplicate, and then call this mWater custom lake. Great, to make sure that it's no longer in my starter content. And now I'm going to take the custom lake material that I've just created, move it out of the starter content into my general materials folder. And once I clear the filter, now in my materials, I have both the custom ocean and the custom lake. Let's pop over and see what that looks like. This is a little bit different. They've, I think, in the two different versions of the water shaders, they've just demonstrated two different ways of doing things. But it's the same principle. We've got a number of different water textures here. One thing I didn't mention is they are using a single texture for all of these and just scaling them slightly differently. And the single texture is the water texture that is supplied from the starter content. Anyway, here we have sort of what we saw before, where there's a texture coordinate coming into a panner node, sampling a texture. So all of these 4 different textures are moving at different speeds and sized differently, moving across each other. These are all coming into a node which blends the near textures and the far textures based on distance to the camera. We're not going to worry too much about that right now. This was also the case in the ocean material, but this collection of nodes is basically a way to say when things are far away from the camera, render them at low resolution, and when things are close to the camera, render them at high resolution. But ultimately, all of those normal textures are coming into the normal node. So we've got a couple of different normal textures layered on top of each other, moving around, creating this sort of swishy calm lake movement. The difference in this material is that there is only one color coming into the base color node. The only thing that is changing over time in this material is the normal. All right. To adjust this material, I'm going to do the same thing that I did in the previous material, which is inject a scale value, or scale parameter, in between the texture coordinate and the panner. And to do that, we need to add a parameter. And then divide the coordinates by that parameter and drag that into coordinates. One thing that I didn't really explain last time is it's tempting to say, okay, that's a texture coordinate node. Why don't I just drag this divide into each of these panners? If we look at the texture node, at the texture coordinate, each one is set up with a slightly different tiling. So this one has 1 to 1, this one is 0.5, this one is 0.3. So by dragging a single texture coordinate into each of these values, we would be removing the point of having differently scaled textures overlapping, because all those textures would be the same scale. So we do unfortunately have to do the process of copy pasting this node a few times. Alright, so here we are. I have divided all of the texture coordinate nodes by the water texture scale. Let's save that and see what happens. I will need to create a material instance from this custom lake master material and drag that onto my water body. And at first it sort of looks like something's gone wrong because all it is a gray texture here. But nothing's gone wrong. The texture is being applied. The material is being applied. It's just, I guess the scale is 0 because I did not set. I didn't set the default value. That's okay. So we might want to set the default value of that parameter as 1. So that would probably look something like this, which, yeah, it's a bit strange. It looks like a default material-ish or something. There's a lot of noise happening. So let's go ahead and reduce the scale of that to, that's maybe a little too much. Sure, that'll do. Well, here we have a similar water, which is a little bit different. Supposed to be a calm lake. We can play around with the color. Say, you know what, I really want my lake to be blue. And where's my sun? Oh, I probably have to refresh the material. Okay, so my sun is over there. I've got a nice little hotspot in the lake. And yeah, it's fine. I mean, it's not perfect, but as a starting point, it is definitely okay. If you look carefully, you can see that there's one pattern that's moving towards us and one pattern that's moving away from us. And under the right lighting conditions, that becomes very noticeable. But then if you move further away or aren't paying attention to it, it becomes less noticeable. The more textures that you layer on top of each other and move together, the less noticeable that this trick will be. Alright, the next modification that I want to make is this lake, the bumpiness, the normal of this is a little strong at the moment. It's very obvious that that this is sort of fake. So I want to see if there's a way that we can reduce the amount of the normal being applied. And we can. If we pop back over into the custom lake material, the normal that's coming in, I am, after all of the water effects are applied, I'm going to add a parameter here to adjust the influence of the normal, the amount that it is applied. So 0 influence means that we will take no adjustment of the normal, so it'll be a super smooth material, and then an influence of 1 will indicate that we are taking whatever is coming out of this node over here. To do that, whenever you're blending between one thing or another, we're going to be using a lerp node. So I'll right click linear interpolate. It's a node that you'll use so often. There's a hotkey for it. If you press and hold L and then click onto the screen, you'll get your lerp node. And I'm going to be lerping from no influence to full influence, which means that I want my full influence to be in my B input. And then in my A input, I'll need something that indicates that the normal is not adjusted. And without going too much into it, a unadjusted normal, or a normal that has not got any bumpiness to it, is essentially the same as saying one full blue. That's the texture that's coming. That's the color that's coming in. So 0 along x, 0 along y, 1 along z, 0 along r, 0 along g, 1 along b. All right, and the way that the value that we're going to be using to adjust these two things is will be a single float coming in as a parameter that I will call normal influence. And normal influence will by default be 1 because I want the full influence to be the default, and I will add a slider between 0 and 1 because that's all I need here. Let's take that into normal. The last thing that I want to do before I bring in the output of my lerp node into normal is to normalize the value that's coming out. So we're going to use a normalize node to make sure that the output of this value is a unit vector, so a vector of length 1. All right, now that we've done that, we should be able to go back into our scene and click on that normal influence. At 0, the water looks super smooth. At 1, we've got the full bumpiness as it was before, and then at some point, you know, everywhere in between, there's a gradient of bumpiness. So we can make our lake a little bit more calm. I'm going to increase the value of this scale a little bit. So yeah, there we go. We've got a little bit more control over the default water material. You can do the same thing with the ocean material if you are so inclined. There we are. That's how you can adjust the basic starter content water materials with a few more knobs to tweak to suit your project and fix the scaling issue. But there is one major glaring problem with both of these materials, both the lake and the ocean. Water is transparent, and neither of these materials is transparent. No matter how closely we look, we're not seeing what's underneath the water. If there is nothing under your water, if you're creating a scene that's on a vast, endless ocean and it's far too deep to be able to see the bottom anyway, then this isn't a problem. But chances are you have some sort of blend between ocean and land, or ocean and boat, and you need to be able to see underneath what's underneath the water. So in the next section of this video, I'm going to go through creating a different type of material to be able to allow that sort of thing, and also emulate a little bit about how water reacts to light. To begin, let's create a new material, and I'm going to call this m_water_depth. Open that up and start building. Okay, the first thing that we're going to do here is change the shading model of the material. Without getting too much into different types of shading models and blend modes, there is a specific type of material called SingleLayerWater, which allows us to emulate some of the physics of how light travels through water without the expense of having a semi-transparent material. Semi-transparency or translucent materials can become incredibly burdensome on your processor, on your graphics processor. This is such a big problem that there is a specific material called SingleLayerWater, which allows us to create deep seaming water while still using an opaque blend mode. As soon as you do that, as soon as you change your shading model to SingleLayerWater, you'll get a big glaring error that your project no longer works. And this error says that SingleLayerWater materials require the use of SingleLayerWater material output node. That's a mouthful. All we need to do to fix this issue is to right-click somewhere in our node and type SingleLayerWater material output. And if you add that, the error changes to you have to have some inputs to the SingleLayerWater material. The inputs that we have are scattering coefficients, absorption coefficients, phase G, and then color scale behind water. If you are using 4.25 or earlier, You might not see color scale behind water. I think this is a new feature from 4.26, so I'm not going to worry too much about that one. But I will go through what each of these other options do. There's a lot of physics behind this, which goes way over my head. But as a sort of general overview or rule of thumb, imagine that for a certain amount of depth in your water, a single light beam will go through that depth. The scattering coefficient is how much of that light is scattered off in different directions. So how much someone standing on the shore will be able to see of that light beam that's going in a different direction. The absorption is how much of that light beam is taken in by the water and absorbed by it. So how much, ultimately what finally reaches the bottom of the body of water. So the higher your absorption, the less of that light will reach the bottom. So the less bright the bottom will be. This also works in the reverse, in that the light is then bounced back into your eye. So if you're looking at something through a lot of water, you will be able to see less of it with a higher absorption. The other thing to keep in mind is that these scattering and absorption coefficients are RGB values. So for instance, with absorption, if we look at a color wheel, if your absorption is very much in the red, that means that the light is taking in that and not allowing it to reach its destination, which means that the light that you do see, the stuff that's coming out of the water, is going to be on the other end of that spectrum, on the opposite, so a sort of bluish teal type color. We'll look at the demonstration of how this works in a second. Phase G relates to the scattering coefficient, and it's basically how much of the light is scattered ahead in the direction of the beam that the beam is traveling, how much of the light is scattered behind in the direction that the beam is coming from, or how much it's scattered all over. And the way that it's listed is that forward scattering is less than 0. So when your phase G is less than 0, the light is going to be scattered forward. When your phase G is 0, the light is going to be scattered all around, so the directionality isn't going to matter. And then when your G is greater than 0, the light will be scattered backwards towards the direction that it was coming from. Let's have a look at this in practice. I'm going to start with the absorption coefficient. So I'm going to add two colors and a single value. Single value coming into phase G is 0, and then the two colors coming into absorption and scattering. I'm going to make each of these colors a parameter. This one's called scattering, and this one's called absorption. All right, and then just so that I have something to play with, we'll look at the rest of these options later, but I do need to make sure that my water is see-through. So I'm going to add a parameter here for opacity. And I also do want to be able to adjust some of the basic options like base color and roughness. I think that's okay for now, although I might add metallic and specular in a sec if this doesn't really work out as I intended to. Let's apply this and create a material instance from this depth water and drag that into our plane. Okay, I went for a coffee and now I forgot where I was. Ultimately, I think here we are at having a single layer water material with a scattering, an absorption, and a phase. Ooh, I should make that a parameter, and I'm going to call this phase. And then a couple of options for the regular material node, which shouldn't be all too surprising at this point. We've got some color coming in. I've set my specular at 0.1 just so that it's not reflecting too much light off the sun, a roughness, and an opacity to play around with. Let's hit apply. I have also adjusted my scene a little bit so that underneath the water plane I've just given my scene a little bit more depth so we can see how the single layer water material is responding to that depth. Okay, so I've activated my plane here, and the first thing that I notice is that I can't really see it, but if I look down, there is a reflection on of the sun off the plane. And the reason that is because by default my opacity, let's open up that instance, my opacity is 0. So if I increase my opacity, I'm now getting the base color coming through and not necessarily the stuff that's underneath. But that's okay, because what I want is I want my water to be see-through. So I'm going to keep my opacity at 0 and keep my roughness at a pretty, I guess it doesn't really matter. 0.2 is fine for now. Because ultimately what I want to demonstrate is this absorption and scattering coefficients. It can be pretty trippy to wrap your head around what each of these is doing without seeing it and without experimenting yourself. So I encourage you to open up Unreal and sort of start playing around with these values and just seeing what type of effects you can get. Let's start with absorption. If you think of a beam of light traveling through a certain amount of water, absorption is the amount of that light that is taken in by the water itself, that is absorbed and not let out back into the scene. So what does that mean? Let's open up absorption and give it a little bit of color. The first thing you'll notice is as soon as you give it any color whatsoever, immediately everything turns black. And that's because we need to use really, really tiny values. So even 0.1 is an incredibly high value for absorption. And if we look at the side of this material, there is something going on the edge. There's like a little bit of a fade, depending on how deep the water is, but it's way too severe for what we need. So even 0.1 is a little too high. Let's try 0.01. Okay, we get a little bit more depth to the water. 0.001. Now we can start seeing what this is actually doing. So for the deeper areas where the light has to travel further, more of that light is being absorbed. And because the color of the light that's being absorbed is white, so all colors, the light that ultimately reaches its destination and sheds light upon the material underneath becomes darker and darker and darker until finally it doesn't show anything at all. Now, if we start adding color to the absorption, if we start saying, you know what, the water is only absorbing colors that are red and orange-ish. Now we start getting the light that's reaching the deeper areas is blue, because the reds and the oranges are being absorbed by the water, and the light that's reaching those areas is blue. So you can see it most on the white cylinder. I think just because the grass is green, we have other stuff going on there. But if I add another plane into the water and scale it up a lot and scale it out a lot, you can sort of start to see what's happening there, where the deeper areas are getting bluer and bluer and bluer until finally only blue light reaches that area. One effect of this relationship is that the more saturated the absorption color, so the more pure reds or oranges that are absorbed, the more the rest of the spectrum is able to reach its destination, so the light sort of on the other side appears brighter. And the less saturated, meaning the more of the general color spectrum is absorbed, the darker the areas in the deeper parts of the water. To get a sort of general bluish, the deep blue thalassophobia type situation going on, you'll want to have a generally reddish orange absorption color, and probably some really, really low value, depending on how deep your water is. So in this case, we have, even though this looks deep now, it's a pretty shallow body of water. If I had a really, really deep lake or something, I might need to decrease this absorption value, just so that to get that effect of, as it goes really, really far down, you get that slow fade. For now, though, for the scene that I have, 0.001 seems to do a pretty good job at giving us deep, dark pits in the water, as well as a bit of a color tint to the shallower areas, as you can see here. You might be able to get a sort of expansive tropical island feel with this type of absorption effect. All right, so that's it for the absorption. Let's have a look at what scattering does. So I'll turn off absorption and turn on scattering. I will also hide the white card for now, just because it looks terrible. Cool. So with my scattering selected, open up the scattering coefficient and let's see what happens. Same as absorption, let's just drag up this value and see what happens. Almost the opposite. In absorption, when we started increasing the color that was being absorbed, the water body turned dark because all of that light was being absorbed. With scattering, when we turn the value up a little bit, all of the light that's going in is now scattered back towards us. So it appears as though this water body is solid white. So again, as with absorption, we probably need to decrease the value quite a little bit. And if we start saying, let's say 0.1, let's have a look at the side here, just as we did before. There's a little bit of milkiness there, some soft gradient towards the edge. 0.01, okay, the edge is becoming a little more pronounced. 0.001, there we go, now there's a fade. You can start to see a little bit of that depth under the water, but it's still quite intense. But you can begin to see what this scattering is doing. It's almost the opposite of the absorption. The absorption, the more the light had to travel through the material, the more of that light was absorbed. But with the scattering, the more that the light has to travel through the material, the more that that light is sent back towards us. Meaning that the deeper areas, in fact, turn more towards the scattering color that we have. So let's say 0.0001. There we go. That gives us a nice demonstration. So the further away that things are, the closer they are to the scattering color, which means that if we now bring the scattering up into the blue area of the spectrum, the further away that the areas under the water are from us, the more they appear closer to this color. And just as with absorption, if we give it a full color, so a specific color on one end of the spectrum, the further away those areas are from us, the more they represent that full color and not white. So I don't know, if you had a lake which had a little bit of milk in it or something, maybe you could use this technique for that. Ultimately though, you will be balancing absorption and scattering together. So let's add a little bit of blue scattering to this light, turn absorption on, and then together we have a body of water that has that feeling of depth to it, especially if we have a terrain that varies. This might not be as pronounced if you have a lake which is a uniform depth. But in this case, because I have really deep areas, shallow areas, and even, let's create, just for giggles, let's create an island that comes out of this water. Oh, that's a terrible island. We can now really start to see the fall off as this island rises up out of the water, and then as the water sort of fades into the deep depths of the ocean. Okay, so those are the two main knobs that you will be adjusting when you use single layer water material, the absorption and the scattering. I will just mention that there is this phase option too. So back in our material, phase points into phase G, and the phase G is the directionality of the scattering. Ultimately, I have not found major use in this, but I will at least point out that it exists. Values closer to -1 mean that the light is scattered forward in the direction that it's traveling, and values closer to 1 means that light is scattered backwards in the direction that it was traveling. The value of 0, as I mentioned earlier, means that light is scattering sort of uniformly all around, and that gives us this murky depth. Use that option at your own risk. I keep it at or around 0 with minor tweaks. So that was an overview of the two main options exposed to you with the single layer water material, or the single layer water shading model. But we still don't have a perfect water material. We now have this sense of depth, and as the terrain underneath the water shifts, we've got this sense that the water gets deeper or shallower in different areas. But we still don't have the sort of top layer. You know, when you look at water, as the water ripples, you notice the rippling movements. There's reflections off the water and things like that, and that's something that we are entirely missing in this material as it stands. The next section of the video moves to remedy that a little bit. We will build upon this single layer water material that we've just created and bring in some of the concepts from earlier in things like reflections and normals and all of that type of stuff. So without further ado, let's pop over into our water depth material. This is the water that I've just shown you. We have our scattering and our absorption coefficients, and we have a couple of default values in the standard material output. But I want to change these default values now to something that more replicates what we had earlier with the rippling and the shifting and the waves and all of that. Without having to redo all of that work myself, I'm just going to go back into our custom material, the one that was taken from the starter content. And just because I liked the rippling effect of the ocean material a little bit more than the lake, I'm going to open the ocean material. And that's the instance. I meant to open the master material. And I'm going to copy as much of this as is relevant to me. Having a look at this, what is relevant to me? Pretty much all of it. I might leave out the roughness because I will deal with that in the other material. But I'm going to try and copy everything that's coming into the base color and everything that's coming into the normal. So copy all of that. And in case you started this later or haven't been paying much attention, the difference between the starter content material and the custom material that I created is that the custom material has this scalar value, the scaling value coming in after the texture coordinates. So I'm going to include that scaling value because that's going to be very important. Copy all of this, Control C, and then move it back into my depth water. Paste that in. Oh, lots of stuff happened. That's not what I wanted. Let's paste that in, move it out a little bit. Oh no, why did that happen? Ugh. If this happens to you as it just did to me, where the comment sections sort of commandeer some of your nodes, you'll just have to go in and clean that up a little bit manually. But all I've done is grab that big node tree and brought it into my new material. This node here will feed into the base color, and this node here will feed into the normal. This node being the node that went into the normal on the starter content material. Excellent. So we have the color coming into the base color, and then the normals from our starter content material coming into the normal. The last thing that I want to do before I test this out is add a normal adjustment, just so that I can reduce the amount that the normal is applied if necessary. Rather than copying it from my lake, I'm just going to go through the process one more time because reinforcement is always great. So I'm going to add a lerp node. Oops, that's not what I meant to do. I'm going to hold down L and click into this to add a lerp node, and I'm lerping from the color blue. That's just 100. Yes, exactly. I'm lerping from blue to the normals coming out of the normal nodes by some parameter which I will call normal influence. And on the output of that, I'm going to normalize, just in case, even if you don't need to. I like to normalize things, and feed the output of that into our normal. Cool. Now with that, we should be able to apply the material, head back over into our scene, All right, so what's going on here? I forgot to, first of all, I forgot to set my normal influence to a value that was not 0. So at the moment, there is no normal influence on the scene. But if I start increasing this, it's apparent that we start getting that bumpy texture on top of the water, which is great. The other thing that we can do is start increasing or decreasing our opacity as well. Our opacity will show us the color underneath, which you may or may not want. We could adjust that to a darker blue if we needed to. But for the most part, I'm happy with the way that the absorption and scattering coefficients are working. So I'm going to keep my opacity at 0, so that the only thing that's being affected by our texture maps is the normal. And then what I might want to do is start playing around with the roughness and bring that down a little bit. Not too much, or we'll get these. Hey, that's not too bad. But I think a roughness value of 0.1 will give us a nice little shimmer on top of the water without covering too much. If the roughness was too high, it would start to seem as though the water was a bit plasticky. So 0.2 or 0.1 should be fine for now. Oh, and of course, we can use the normal influence to reduce and increase that if we need to. All right, I had a bit of a moment, and I have changed the shader that I've been using from the ocean influence to the lake influence. So I brought in all of the nodes from the lake, which ultimately it's condenses down to the single normal input, and then I have some color coming in, roughness, opacity, and specular, all as parameters. Just to give a different feel of, just to show a different version of what we're doing, and that all condenses down to a material that sort of looks like this. Very similar to the lake, except we now have that added depth as well. There's still a lot to do. Our reflections aren't perfect. You might notice that when we're looking down, the reflections sort of disappear, and that has to do with screen space reflection capturing. By default, you can only display, you can only reflect what is currently in the scene. For some reason, I'm pretty sure I had this working, but for some reason, just simply adding a reflection probe doesn't seem to be working now, even after we build the reflection captures. I'm going to investigate that and see what's happening there. But either way, there's still a lot of work to be done on the reflections. There's some stuff that we can do so that when you go underwater, it seems as though you are actually underwater. But I will save those for another video, so keep your eyes open for that. For now, I hope this has helped get you to a place where you can at least start experimenting and exploring what the water options are in Unreal. And especially with this single layer water material, there's a lot of different things that you can do for different types of water of different quality. So it's a place to start. All right, that's it from me. Good luck with your water projects and take care.